I just got this HP8643A signal generator and I'm going to try repairing it. I bought it for parts of repair. The seller had photos of this one with the display lighting up, only one dash on the first segment on the left. Sometimes they boot up with error codes that start with either a plus or a minus. This one has just the minus and nothing else going on. So I'm not sure yet what I'm getting into. One thing I didn't notice when I bought it was it's missing one key here on the marker 1, and also was a bit disappointed in that, but the RF output connector is a bit bent, so it's definitely been dropped at least once. Well, taking off the top cover was harder than expected. For one thing, this rear screw in the middle of the cover, it's supposed to be a captive screw, and you can kind of see the ring here for a snap ring, and was missing. And there was a calibration sticker on top of it, but it was all ripped. And when I finally got it loose, there was a fair amount of corrosion here, and this part fits in pretty tight around the front panel. Same thing on this side, so maybe that was holding it in. Alright, so I got this on its side, opened the cover off, I actually just powered it up. But I noticed there's this connector. I'm not sure where it goes, if it's supposed to go in one of those voltmeter or power meter inputs, or it was just something else tucked in there. I'll have to check. There's two LEDs coming up there. Now if I turn this on, there was a bunch of blinking on these LEDs, which is okay, but it should stabilize. Oh well, actually, I had to interrupt that test when I noticed the unmistakable smell of burning components. I didn't notice any magic smoke coming from anywhere. I thought it probably came from the power supply section, which is mounted to a plate on the bottom rear of the unit. And there's a board on the other side of this, plus another smaller board about the size of the hand here, and I can sort of start tipping it out here, but the PCB is getting stuck on a few mounting tabs, and there's a heatsink that just won't really cooperate. So I'll have to work on this a bit more and find out. I hope I don't have to take out the whole rear section, because it's a lot of screws holding it in there, and I'm afraid, well, the frame's probably stiff enough not to collapse, but still, if I can avoid that, I will. Right, finally managed to get the power supplies out. I gave up and I removed the 4 screws on the corner of the rear panel like this, and just by prying it out just a couple millimeters, I was able to pivot this and pull it out, and at the same reaching in to disconnect this is a line in, I think. This one I'm not sure. There was a fan coming in right in here, and at the other end there's the main output going to the I/O board, the one that's sitting on top, and there was this ribbon cable connector too. Well, at a first glance I see a couple refa caps, one, two, another one on the mains filter. There's a bunch of those evil LXF caps. I haven't seen any leakage, but I'm going to make a shopping list and replace the whole lot of them probably. This is the smaller power supply. It's a 40 watt 24 volt power supply. It's the one bolted to the rear panel, and it supplies standby power. And I just did a quick test with the multimeter here with and without a load, and it seemed to be running okay despite having those suspicious capacitors. I also tested this second power supply on its own, and everything seemed to be okay. All the voltages right on target with and without a load. So I set those aside, ordered some parts, and started looking at other areas. Well, I found something. A crime was committed. I was going to remove the DCU board, the first one on top, just to get the ROM chips dumped while I'm waiting for capacitors. And I noticed it was jammed in there pretty good, and the DCU board isn't quite in those little plastic rails like here. And the second one, that's the attenuator board. That's even worse. Check it. It's not even in the bottom groove, so the PCB is bent. Like, who does this? Seriously. Alright, finally got the DCU board out. I guess DCU stands for Digital Control Unit, probably. I think it's the only, it's the main CPU inside the machine. There's another one in the front panel, but this one does most of the work. And here it is. It's a 68HC 000. Yeah. Some ROM here. Those 4 would be the battery-backed RAM, with the battery right over here. Good old nickel cadmium. This one hasn't leaked yet. Can't believe how lucky this is. It's going right into the trash. I'm putting something else in there, probably NIMH, and that's 9914. That's a GPIB controller, and a bunch of other stuff that doesn't really matter. Okay, so this is a few days later. I replaced a bunch of capacitors from the power supplies. There were 3 boards in there, 2 off-the-shelf power supplies, which has a lot of... I didn't test all of these, but I just assumed most of them were either bad or going to be bad soon. A few Rifa caps and other LXF and TXF series caps. So I did those. The third board was an HP board, and it was just a filter board with a bunch of inductors, some what appeared to be overvoltage crowbar circuits, and regular capacitors, which all looked good. And I also ordered a replacement battery for the memory backup, which is right here. I didn't find a very nice drop-in replacement for the 3.6 volt NiCad that was there, but I did find a 3.6 volt nickel metal hydride, and I mounted to the back of the PCB, and there's just enough space in there to slide it in the board. It fits in right there. And this piece of hard line here just bends the smallest amount when I install the board, and it fits well now. And I also reseated both of these cards, which were bent way out of shape. They weren't even in the plastic guides there. It was completely insane. I also found where that loose connector, which is tucked in there, is just routed from the rear VM BNC connector voltmeter. It runs to one of these two SMC, whatever this is. So that was okay. Other than that, there doesn't seem to be anything missing, so I'll plug it back in and see if it's any better. Alright, by the way, if anybody knows where I can find a replacement keypad or some way of restoring one of these, one of them's disappeared. It's only one of the marker buttons, so it's not a huge deal, but it'd be nice if I could replace it. So here's power on. Oh, looking good so far. Let me see. Get this bit. Well, that's in a lot better state than it was. Doesn't smell like capacitors either, so that's good. Apparently this is going to take a while, so I'll just come back in a few minutes. Okay, finished calibrating, and I have a result code 4301122. Been doing a bit of reading. The 3 digits at the end aren't really important, although for this instrument, if I'm reading this right, 22 means it should have a doubler, a comms discriminator, and a frequency counter, and that's absolutely not the case. So that's either because my unit is weird, or the manual that I have doesn't cover these serial numbers, and maybe they changed the interpretation for those 3 digits, so I'm not going to worry about that too much. So it is an unsigned result code, which means something happened during calibration that prevented it from even doing that. And I have these two LEDs, NF, which is fractional N divider and VCO OOL for out of lock. And I also have some other codes inside there. Let me just hook this up again. What else do I have? I have hardware failure number 4. Number 4, I looked it up. Those are in the user's manual. Number 4 means modulation distribution failure. Calibration error 2, that one was expected. Some hardware failure prevented it from calibrating. I have 24. That's VCO frequency lock loop out of lock, which would be one of those red LEDs. And hardware failure number 23, that's fractional N PLL out of lock. So that would be the other LED. And that's it. So this is getting a bit more interesting. There's some tests suggested for the 4301 error code, so I'll see what those involve. I just messed around with the unit a bit more, and I did what they call in the manual the ILD, the instrument level diagnostic, and to do that you preset the instrument, so green button, then you press special and it's code 320, and you press enter and it runs the self-test again, and you can see the LEDs cycle around the top. And it finished this time with the same code, but it did give me a negative sign, which means it's the issue is not, let me see, how did they say this? Yeah, I wasn't able to precisely determine the source of the problem. But I did notice something pretty interesting. Let me just check the messages. 4.2, yeah, okay, those are the same. If I go special. 320, enter. So there's test instrument, which is the whole thing, but I noticed there's a couple more tests I can do. I/O board, let me see, instrument counter, doubler. Yeah, doubler. Why do I have the doubler there? Anyway, ALC, fractional N, VCO. But those are pretty interesting. So let me try the. Let's try with the VCO first. Press OK. Cool. Okay, so I'm getting a different result code. Right, so I just looked up this number, and I hope it's the right thing. It says standard VCO, which I already kind of expected. J6 test 1A, and the test 1A involves me plugging the internal voltmeter and doing a couple tests. So I think I'm actually going to do that. And just for fun, I'm trying some of the other special tests in there. So I just did the fractional N self-test, and this is the code that it gives me, and it points to the fractional N board connection J2. Here's a quick look at the block diagram for this instrument. So the two errors I was getting, the first one said it came from the standard modulator. No, I'm sorry, the first one was on the VCO board connection J6 here, which is the FM drive. That's coming from J2 on that other board, so that's exactly what the other error code was telling me. So it's definitely suspecting something either about this connection, or either the source of the signal, or whatever the VCO does with it. Okay, so I'm back on the VCO self-test. And so the thing to do is to disconnect J6, and luckily they leave you with enough wire to run it all the way over to the DCU card, which has one power meter and one voltmeter input. So I have this wired up, and then you're supposed to go in special 3, 2, 1, press enter once, and continue test. Okay, interesting. So I'm getting a different code here. Let me see what that. Sorry about that. I ran out of space on my memory card, so I was just about to look up this error code, and it's again from the standard modulator connector J2, but this time they want you to do a different test, number 3A. And in test 3A, what you're supposed to do is replace the cable with one known good cable that you should have on hand from a certain service kit. So what I did instead was just test the cable on its own, just a continuity test, and put it right back there and continue the test. So I figured it's not a high frequency signal that goes on the FM drive line, and it would give me at least somewhere else to look, just being able to get past that step. Next, after running that special 321 function again to continue the test, it ended with a positive result code this time, meaning it did isolate the problem. And looking up this number in the list points to the standard modulator board, which is maybe not very surprising. So at least now I know where to look closer. Okay, so I took the probably faulty module out. I'm just removing the last screws here. Cool. So J2 is, hold on a sec. Oh, okay. J2 is the second one on the right. At the other end, over there. Let's see if I can get this. So it would be this one here, so. Well, nothing obvious over there. Oh, hello. Alright. See if I can zoom in on this. Here's a closer look at this burnt inductor. It's probably what I was smelling the first time I powered on the machine. So I did find a very rough block diagram for this module, but there's a bit of info missing, and some of the pin numbers that they have for J6, this 15-pin connector, it doesn't make sense. But what I think is, what I'm pretty sure now is these are just an LC filter, not a resistor as I thought before. And this is the one that I just removed. Thankfully the board underneath is clean. There was no burnt traces, so something in here is probably shorting out. I'm hoping it's one of the tantalums and not one of the ICs, but we'll see what I can find. I don't have the schematics yet. I'm tempted to buy them, but I'm still going to give it a try. I have a power supply here. I found which one is the one that was shorted was the plus 15 rail. So I'm going to set a very low voltage on my lab power supply, feed it on that, well, not on the pin obviously because there's no more inductor, but right to the pin here. And I'm going to look at the components that I suspect most. So a couple of these op amps that are fed right from the plus minus 15 rails, and a couple capacitors too. And if nothing's blowing up, then I'll use my bench multimeter and try and see if I can follow the voltage drop. But I think that's going to be a bit difficult on this board because it's a 4-layer board, and I can tell most of the power traces are in the middle layers, so it could be a bit difficult. Well, the whole thing wasn't very scientific. I ran a bit of current through the plus 15 volt rail, and I don't have a thermal camera, and it was hard to tell. I thought maybe this capacitor was getting a bit warmer, but I also had a hunch it could be this one, so I decided to just remove it and test it out of circuit. And sure enough, this little turd is a short circuit. Interestingly, it's most of the tantalums on this board are 3-leg versions, and I had to look it up, and the manufacturer claims it's mainly to prevent installing these backwards in a board. Well, I went off on a bit of a tangent there. I was trying to measure one of the good inductors there just to validate that my reading was good. They're 10 microhenry inductors. Eventually I should probably check on the actual part list and see what they say about a current rating. I measured about 0.7 ohms resistance, and this one I had stock. I pulled that from somewhere, I can't remember where. It's also 10 microhenry, but the resistance is 0.4 ohms. It's probably won't make any difference. It's just an LC filter on the plus and minus 15 volt rails. Capacitor, I found a same value, same voltage rating tantalum cap. I've had these forever. They're probably almost as old as the ones in there, so I'm not planning on leaving that in there very long, just to finish my testing here. Okay, so I got that module plugged back in. Whole thing's ready to go, so we'll see if it still works. It's probably going to calibrate. Yeah, jeez, okay. And it finished calibrating successfully. I also ran the other ILD tests again, the VCO, fractional N, divider tests and everything was okay. After that, I just tried generating some basic unmodulated signals. Right, so I got my power meter hooked up to the output. It's set to -40. It's a bit off, but I'm not sure who's to blame, if it's my uncalibrated RF meter or this thing. So let me just change the output. That's -30. Oh, that's a lot better. -20. Okay, pretty close. -10. Also pretty cool. Let me change the frequency here. At -10 dB, that's pretty close. Okay, then go higher. Alright, 0 dBm. Okay, pretty close, pretty close. So I want to say this works. I could try the modulation, but I really don't know how to work this at all. But it's not causing any more errors. The attenuator seems to work. I was pretty worried about that too, but so far it seems pretty good. This one, the 8643A, has apparently the electronic attenuator, which I assume is pin diodes, instead of the mechanical attenuators. I think I prefer the pin diodes. I think they're a bit more reliable in the long term. They're certainly, on paper, they're not limited in the number of cycles. Well, that's it for this repair. Thanks for watching.